Hi everyone. In this lesson, we're going to talk about function notation. We're going to talk about it in three different ways. First, we're going to look at a graphical example. Next, we'll look at a table in a real-life example. And finally, we'll look at some problems algebraically. So thus far, we have talked about graphs and how to interpret graphs. And we've talked about variables, independent and dependent variables. And then we moved into talking about the definition of a function. So today we're going to fully round out your knowledge of functions, graphs, and variables by making sure that you understand this new notation called function notation. As a reminder, you should be aware of the independent variable, which we frequently call x in mathematics, the dependent variable, which we frequently call y in mathematics. You should be aware of the definition of a function, which means every input has exactly one output, or every x value should have exactly one y value. And you should be familiar with reading graphs and knowing that the independent variable is always listed on the x-axis, the horizontal axis, and the dependent variable is always listed on the y-axis, the vertical axis. Okay, so with all that in mind, we're going to move right into this new notation. So typically, you'll see notation that looks like a letter here, and then parentheses, and then the independent variable name on the inside. So this function is called h, and in this particular case, y equals h of x. So what that is saying is that y is a function of x, and that function's name is h. You're probably used to seeing this as y equals f of x, which is also fine to have as a function, but I wanted to show you a new notation here to make sure that you feel comfortable calling these functions whatever you want. So a function might be called h for height, or you might call a function v for velocity, etc. Okay, so let's talk about what this means. H of x means that I'm asking you to find me a y value where the x value is the number that you see inside the parentheses. So this first question, find h of -3, that means that x equals -3, and you're looking for y. And really you're looking for that exact point. So you're looking to find where, if you can find the point on this function that has the x value of -3, then you just list the y coordinate. So here's where x is -3 and the y value is 0. So in this case, we would write h of -3 equals 0. So that's the answer for part A. And that's what you're doing. This point is the same. This notation is the same as the point -3, 0. So that's really what that means. You're just using a different type of notation to represent a coordinate point. Now, obviously, it's a little bit more powerful than that because I could use this notation to tell you that this whole graph is a function of x by calling it h of x or f of x, etc. Okay, so let's do another one, and then I'll let you try some of the rest. H of -1, what does that mean? This means that x equals -1, find y. Okay, well, if you look at where x is -1 and come up to the graph, you'll see that y is 2 because this point right here on the graph is -1, 2. So that means h of -1 equals 2. And this notation is the same as the point -1, 2. Just so you really see that that's what you're doing. It's just a new notation to represent x and y. X always goes on the inside of the parentheses. Y always goes on the outside. Okay, go ahead and pause your video now and try parts C through G. Stop at part H. Don't do part H. Okay, I'm going to go through these quickly now that you've paused your video and had time to think about this on your own. So h of -4 would be right here. The answer should be 3. H of 2 is over here. Here's where x is 2, and the y value of that point right there is 1. So the answer there is 1. H of 3 is right here's where x is 3, and the y value of that point is also 1 again. H of 4, that would be right here, and the y value is 0. And H of 5 was kind of a tricky challenge question because there's not actually a point at x equals 5 on this graph. So there's no actual point there. And the convention we use to show that to readers is an open circle. That's why it's not shaded in. It's not a filled in circle. So by convention, that means there's not actually a point there. And so what we would say here is does not exist, which you might see abbreviated as DNE, or you could say no solution as well, because that means the same thing. There is no answer to the value of H of 5 because there is no point on this graph. It would be similar if I asked you, what's H of 6? Well, H of 6 would be over here, and the graph stops right there, so there is no value. Okay, so these next 3 questions, they're a little bit different because now you're asked to find x. This says for what value or values of x is h of x equal to 3? Now remember this notation up here, y equals h of x. So that means this whole thing, h of x, that equals y. They mean the same thing. So really, what am I asking you? I'm asking you to find x if y equals 3. That's what I'm asking you. Again, it's still, you're looking for a coordinate point, and the answer would just be the x value of that coordinate point. So let's go find the point on this function where y is 3. So I'm going to come up the vertical axis now. Here's where y is 3, and the x answer there is -4. So we're going to put here x equals -4, and if you wanted to write that using function notation, you could say h of -4 equals 3. And then you could also say, let me move that in the middle, this is the same as the point -4, 3. You don't want to write your answer, like your answer is right here, it's -4. So let me just highlight your answer there. But it might help to write out this notation fully, and it might help to see the coordinate point that you're looking at fully. But the answer is not the coordinate point. It's only either the x value of the coordinate point, as in this case, or like in the previous parts that we did, it's the y value. Like in this case, the answer here was just 2, and that's why we put here equals 2. Okay. Now, because this is a function, and we know the definition of a function means every input only has one output. That means all of the answers for parts A through G should only have one answer or no answer, right? Or no solution. But see how we only have one answer for each of these? When you see questions like parts H, I, and J, these could have more than one answer, and still you would still have a function. So let me show you what I mean. Y here is 3. So here's where y equals 3. Now there happens to only be one point here, but if I scanned left and right, like this graph could have come all the way up here and come back down. Then there would actually be another answer. So you might have multiple answers for what the x value can be if you know your y value already, which we're about to see in part I. So go ahead and pause your video now and try part I. Okay. So what is this question asking? This is asking you to find x if y equals 0. All right, what does that mean? Y equals 0 means it's along this axis, it's along the x-axis, because you haven't gone up or down at all. So here's one point where y is 0. That point is -3, 0. So one point for the x, one value for the x would be -3. Another value for x would be 4, which you could see over here, and you can also see we wrote here h of 4 equals 0. So we already knew that one of the x values is 4 because we figured it out in part F. But just to round out our knowledge, those are the two answers there. And if you wanted to explain why, you can say because h of -3 equals 0 and h of 4 equals 0. That's why you have two answers there. And what about for part J? So if you haven't already tried this, go ahead and pause your video now and try part J. Okay, so the answer here is no solution or does not exist. You can put either answer, they mean the same thing. And why is that? Because where is y equal to -3? That's down here, the bottom of this graph, and there is no point on this function anywhere down here. So we don't have a point on this function that has a y value of -3. So you could explain that too if you'd like, because there is no point on this function that has a y coordinate value of -3. Okay, so this was very abstractly looking at function notation. In the next lesson, you're going to do a Desmos activity that helps you to think more concretely about function notation in the context of real world situations, so that you would have a meaning to what this point literally means in terms of the independent variable and the dependent variable. So keep that in mind. We did this devoid of context. This wasn't modeling any real world application, but most of the time you are modeling something in the real world, and it helps to know what these things mean in context. So we're going to do an example of that now, but in the next lesson you will do lots of graphical examples of that. Okay, so if you work for an hourly wage, your gross pay is a function of the number of hours you work. All right, so let me help you break down this phrase right here. So your gross pay is a function of the number of hours you work. That sentence, that is super important. The way that it's written, you can translate that into mathematical function notation. And so we could say something like, your gross pay, I'll write it all out so you see it. Is means equals. So your gross pay equals a function of, you could call it f of, or you can call it h of, or g of, whatever you'd like, the number of hours you work. Okay, so the way that this has been written, your gross pay is a function of the number of hours you work. What is inside these parentheses is always your x variable, which is your input variable, and your independent variable. All of those mean the same thing. So what is the input variable? The input variable is the number of hours you work, and the output variable is your gross pay. And this should make sense as well, because if you go back to our lesson on independent and dependent variables, your gross pay depends on the number of hours you work, right? If you know how many hours you work, you can tell me exactly how much money you'll make for the week, or however you're tracking money. So this should confirm with what we've learned earlier. Let's complete this table together. If you earn $10.50 per hour, go ahead and complete this table. So if you work 0 hours, then you should make nothing, right? If you work 3 hours and you earn $10.50 per hour, I'm just going to do in my calculator $10.50 times 3 hours, and so you would make $31.50. What if you work for 5 hours? Let's see, you'd make $52.50. This one is $73.50. This one is $105. And then this one is $126. Okay, so that would be your gross pay if you worked these various different hours. Again, even this table, the way that it's set up, if you know how many hours you work, you can figure out your gross pay. Why is that? Because your gross pay is a function of the number of hours you work. That means given the input value, you can find the output value. Okay, so we're going to talk a little bit about what this means. So let n represent the number of hours worked and f of n represent the gross pay. Find f of 5. So pause your video now and see if you can interpret this function notation using this table. Okay, so f of 5, whoops, not t, f of 5 is 5250, and we found that by noting that n inside the parentheses is the number of hours worked. So if you see a 5 inside here, that means go find where the 5 represents number of hours worked and tell me what is the gross pay amount. What's the Y value, in other words. Okay, and then part D, this says write a sentence explaining the meaning of f of 10 equals 105. So see here we got f of 10 equals 105. So what does that mean in simple language, right? In non-mathematically complex language. This means after working 10 hours, you will earn $105. So that's how you say that, devoid of any mathematical complicated sounding words, right? I didn't use X or Y in this explanation. I didn't use the word function, nothing that sounds mathematical. So in other words, when you explain the meaning of something, you want to use as simple language as possible so that somebody who's not even in our class would understand what this means. Okay, so as a reminder, what you're going to do in the next lesson is you are going to study real life context just like this and work on writing function notation and interpreting it and understanding what it means. Today, however, we're only going to do that one example in a real life context. So the next two we're going to do abstractly. So that means there is not going to be any context. So I wanted to show you how to do this algebraically. How do you work with function notation if you're not given a graph or if you're not given a table like this? What do you do? So here's this function, f of x equals 2 minus x squared, and you're asked to find f of negative 1. Now, if you had a graph given to you, you could just go find the point where x is negative 1 and go up or down, look for the point on the function, and then tell me the y value. Because you don't have that in this case, what you're going to do instead is you're going to just plug in this x value in for x into the function here. So let's do that together. Anytime you plug a number into a function, always use parentheses. And that's the reason why that's important is because if you don't put parentheses here, you might multiply this negative first, and then you'll think that the answer is 2 plus 1, which it's not, because first you have to square this negative 1. That's why these parentheses are important. So you should always put parentheses when you're plugging in a value into a function. They can't hurt. Sometimes they're unnecessary, but sometimes they're necessary. So it's better to be safe than sorry. So you should just always use parentheses. Okay, so if you square negative 1, you'll get a positive 1, and 2 minus 1 is 1. So f of negative 1 equals 1. So again, if you were to see this graphically, you would have seen a point at negative 1, comma 1. So let's just make sure we drive that home. This is the same as the point negative 1, comma 1. That's the point you should see on this graph if you were to graph this function. Why don't you try part B? How do you find f of 2? So pause your video, unless you've already done so. Okay, so f of negative 2, let's just put it up here, equals 2 minus parentheses 2 squared. Now in this case, the parentheses don't really make a difference. This would be the same if you wrote it like this. But it helps my eye to remember to do the squared first. Like, don't do 2 minus 2 and then square the answer. That's not the right order of operations there. You have to do parentheses first. So that's why it's helpful to see the parentheses. All right, so what is 2 squared? It's 4. So we're doing 2 minus 4, which is negative 2. Again, this is the same as the point 2 comma negative 2. So that's what you would see if you were to graph this function and look for where x is 2. You should see the point is at 2 comma negative 2. Finally, what's f of 0? That means plug in 0 for x. And you will get just 2. And that is the same as the point 0 comma 2. Okay. So we're just going to do one more example to really drive home this idea of function notation and keep in mind, these can get pretty complicated, but we're not going to do too many functions that look advanced in this class. But if you take a future math class, you might see some very complicated looking functions. Okay, so here's the function f of x equals square root of x. Find f of negative 2. Well, if you try and do this, so what I'm asking you to find is the square root of negative 2. And if you put that into your calculator, you should see that you will get some kind of an error. And that's because the square root of negative 2 does not exist. So the answer here should be DNE for does not exist, or you could put no solution. So don't always expect to get an answer. It's possible that there could be no answer, and make sure that you just write no solution or does not exist and then circle that as your answer so that you know that's the final answer, that there is no answer. If you're wondering why it doesn't exist, it's because there is no number that when you square it will give you a negative answer. So like if you think about it, if you try and take negative 1 and you square it, that's going to be negative 1 times negative 1, which is positive 1. And if you try to take a positive number and you square it, that's the same thing as 1 times 1. And so you're still going to get a positive answer. So you're always going to get a positive answer when you're squaring something, which means you can't find the square root of a negative number because this is like, you know, the opposite is squared. So you're never going to get an answer there. Not a real answer, at least. It could be imaginary, but we're not going to get into that in this class. Okay. So now f of 0 means substitute in 0 for x into the function, and you'll get the square root of 0. So you should check that on your calculator to see, do you get an answer or do you get an error? If you get an error, then the answer is does not exist. If you get a number, then the answer is whatever number you get. Okay, so hopefully you've tried this on your calculator. If not, you're grabbing your calculator right now and you're typing in square root of 0, and you're going to pause your video and see what you get. So when I did this, I got 0, and hopefully it should make sense why you got 0, because 0 squared, which is 0 times 0, equals 0. So that's why we got, you know, an answer there. So that is possible. The negative numbers, they're not possible. But 0, you can square root 0. And you can also square root a positive number. So when you plug in 1 for x, you should get 1. The square root of 1 is 1 because 1 times 1 equals 1. For this last question, so this is again driving home the idea that you don't always have to just find f of a number. You could be given f of x equals a number and then asked to find x. So this is very similar to the problems we did up here, where h, I, and j, we were actually finding the x values. So this is the same thing. So now you're given f of x equals 4, or I could say that differently, y equals 4, and you're solving for x. And then just internalize the concept that y equals f of x. Those are the same thing. So wherever you see an f of x, that's the same thing as y. That's the same thing as your dependent variable, whatever you want to call it. Might not be called y. So if you see something like f of x equals the square root of x, that's the same thing as y equals the square root of x. That's what I mean. I want you to see the connection between these things. Y is the same thing as f of x. So if f of x equals square root of x, this is just like saying y equals square root of x. Now, to answer this specific question, so this was more, you know, this was in very general terms. This is specific to our example here in number 4, and now we're going to actually answer part D. So if y equals 4, or if f of x equals 4, that means 4 equals the square root of x. And now you just have to solve for x. Now, maybe that's easier said than done because you have to deal with the square root here. So how do you get rid of the square root? You just square both sides. So if you, here, I'll show you. If you have the square root of x and you square both sides, the square root and the squared are opposite operations, so they cancel each other out. So what you're left with is 16 equals x. And you could always check to make sure. So if that is the right answer, then when you take the square root of 16, you should get 4 because that's what we said the y value is. And we're saying that x should be 16. And so yes, that is true. So there you go. There's your final answer right there. It's x equals 16. Okay, so that covers function notation for this video. If you're learning this for the first time, be very patient with your learning because it can take a while to get used to seeing this new notation. Like you're essentially learning a new language. So do lots of practice problems, but be patient with your understanding. In the next lesson, as I've said a few times in this video, we're going to do a Desmos activity where you will see hands-on a real-world example and how you can use function notation to describe certain things you might see in the graph modeling a real-world situation.